Hi, this is the first lesson for Unit 1. Unit 1 is going to deal with identifying chemical and physical properties, chemical physical changes, and classifying matter. And so I guess since we're starting out here in chemistry, we need to kind of know what chemistry is. And so by definition, chemistry is the study of matter and energy. And so, let's focus on this word matter. All right, so that's a word you've probably heard before. So, matter, I guess a textbook definition of matter, and this is the one that you've probably heard before, maybe heard in middle school. Matter is basically anything that has mass and takes up space. And so, takes up space, there's a word for that, it's called volume. All right, so anything that has mass, and mass is basically just a measure of how much material is there. And then volume, like we said, is just the three-dimensional space it occupies. So chemistry, that's what we're going to look at. We're going to look at the matter and how matter undergoes changes as it, interacts with energy. And so one of the things as scientists we need to do is we need to be able to communicate to other people about our observations of the natural world. And so we need to use some kind of properties to describe matter. And so, one of the things that we use to describe matter is going to be a physical property. Now, the thing you have to understand about a physical property, they're observed characteristics, okay? And so, this is going to use our senses to make observations, all right? And this is going to be done without altering the makeup of that matter. Okay, so we can observe it, and it's not going to change what that substance is. All right, so we're just going to like look at it, feel its texture, all sorts of things like that. And so these are all examples of physical properties, things like hardness. For an example, you guys may know like diamond, it's a form of carbon. It's one of the hardest substances known to man. Whereas other things, like gold is not a very hard, it's a very malleable, very bendy metal. If you've ever seen any of those movies where they'll have like an old prospector, digging for gold nuggets, the first thing they'll do is they'll pick them up and they take them and they bite them. And the reason why they're biting them is they're seeing if their teeth will dent it because there's a mineral that looks a lot like gold. It's called iron pyrite, also known as fool's gold. Much harder than actual gold, and so one quick an effective way of determining if you've got a real gold nugget or not is to bite it. And if your teeth can dent it, yeah, it's soft. It's probably real gold. We just talked about mass. Mass is just the amount of material present. Color, observing color. Conductivity. Okay, when we're talking about conductivity, let's go back here. Conductivity, we could be talking about like heat or electricity, all right? So electrical conductivity when we're talking about conductivity. Do me a favor as far as heat is concerned. If you're sitting there somewhere, you're sitting, maybe you have a piece of metal nearby, like maybe the leg of a chair or a table you might be sitting at. Do me a favor and grab that table leg with one of your hands. Okay, and then you've got hopefully a piece of paper, notebook. Hopefully you're taking some notes of this stuff. Put your other hand on the piece of notebook paper. Now, as you feel those two substances, one of them is going to feel colder than the other one. I'm guessing it's probably the metal leg of the chair or table or whatever, right? And the reason for that, metal is a really good conductor of heat. And so I promise you, the temperature of that chair leg is the exact same temperature as the paper you're touching or just basically anything else in the room that you're in. If something doesn't have energy actively flowing through it, everything's room temperature. The air, the floor, these things feel like they're different temperatures, but that's simply because they're made of different materials and some of them are more conductive than others. All right, looking at some of these things like boiling point, melting point, all that stuff. Those are changes in state. We'll talk about those. Volume, we talked about volume already. And then density. Density is this here. I'm going to add a slide here. So density, by definition, is simply this. It's just the mass per unit of volume. Okay, so how much something weighs in a certain amount of space. So there's another way you can write this. You can write it like a formula. Density is some unit of mass divided by a volume, or you can also do it like a formula like this. The big D there is for density, M over V, density mass per unit of volume. A way you can remember this, and you won't need to know this for the exam or anything, but it's just something, a little drawing here I can draw, where we have, isn't that special? We have a bow shooting an arrow through a heart. You'll notice that the bow looks a lot like the letter D. The top of the heart looks like an M, right? And then the bottom of the heart looks like a V. And then that arrow looks like the division sign. So that's a way you can kind of remember the formula for density, mass per unit of volume. I might link a couple of videos to you just so that you can look at like objects that are like very dense and objects that aren't very dense at all. So like, for example, mercury. Mercury is an element. It's very dense. Mercury is a metal that's liquid at room temperature. Totally crazy metal. If you had a 5-gallon bucket of it, it'd weigh between 600 and 700 pounds. It has a lot of mass for a relatively small amount of volume. So things like that, very, very dense. Things that are not very dense, think of things like helium. And you guys are aware helium's not a very dense gas. I mean, if you put helium in a balloon, it doesn't weigh very much compared to its volume, so it floats. It floats in air. So anyway, density, just how much material is in a certain space. All right. Chemical properties, that's the next thing. So we talked about physical, which are just observations using our senses. Chemical properties are basically going to be observations that we make when we look and see how substances react as they undergo some kind of chemical change. And the best two examples I can give this to you are reactivity and flammability. I'll have to show you a video of a demo with maybe just like some of the reactivity, like copper with nitric acid. That would be chemical reactivity. We'll talk about things that are evidence of reactivity. Flammability is another example. So flammability would, if you guys know something's flammable, it means it burns easily. You're able to set it on fire. And so all these things are examples of chemical properties. So copper reacting with nitric acid. I'll maybe link a little video so you guys can see that. Iron reacting with oxygen to form rust. Okay, once again, that iron, once it rusts, you can't get the iron back. It's changed. It has new properties. It's no longer rigid and hard. It's crumbly, and you guys know what rust looks like. Oxygen is flammable, so I don't know if you guys did this when you're in elementary school, when you did fire safety. Maybe the fire department came out and talked about, having a plan in case your house ever started on fire, evacuation routes, all that stuff. One thing they might have talked about is that in order to have fire, you need 3 things. You need fuel, you need oxygen, and you need some kind of energy, some kind of ignition source to start that fire. So if you have those 3 things, you've got fire. Take one of them away, you don't have fire. But that definitely is a chemical change. So once that material burns, you can't undo it. And then helium is non-flammable. So we talked about helium, in the previous slide when we're talking about density. Helium is not reactive. It is completely inert. We'll learn why later in the course, but that's one of its properties. It doesn't burn. It doesn't do anything. And so even though it doesn't catch on fire, it doesn't react, you're still testing a chemical property, or that is a chemical property of helium. It is unreactive. In fact, it's so unreactive. If you guys ever get an opportunity to travel to our nation's capital, Washington, D.C., stop by the National Archives. You can see a lot of these documents you've learned about in school. Things like the Bill of Rights are there, the Constitution, the Magna Carta, like all these documents you've read about in history books. You can actually see they're on display. And these documents, are several hundred years old. And to prevent them from further degrading or decaying, they keep them in these glass cases. And these glass cases are filled with helium because it won't react with the paper, react with the ink. So check that out if you get the opportunity. All right, so a little quick check here. Let's see. I don't know. Okay, well, it says it's still recording. Hold on here a second. All right, let's do a little quick review here of identifying things, either physical or chemical properties. First one says the volume of water is 10 milliliters. Well, basically what you're doing is you're using, a piece of graduated glassware, graduated cylinder to measure how much water is there. By simply putting the water in the graduated cylinder doesn't affect the water in any way, shape, or form. You're just telling the quantity of water there. That is indicative of a physical property. Next one, it says the apple slice turns brown after it sits on the table for 15 minutes. And so, you look at this, and you're like, well, brown, well, that's a color, and you said uh, color was physical. Physical color is physical if you're talking about like the color of an object. Like I say, the stop sign is red. That is just a property of the stop sign. But the key is here is that it's turning brown. So it's undergoing some kind of change. Because if you cut an apple, normally they're not brown on the inside. They're, a white kind of fleshy color. And the key is it's turning brown as it's sitting on the table. That means that as you cut it, it's exposed to the air and it starts breaking down some of the sugars and things that are in there. So this is actually going to be chemical because of the fact that it's turning brown. Okay, the next one, it says water boils at 100 Celsius. So anytime you're talking about changes in state of matter, so boiling, freezing, all that stuff, we'll talk about that here in a minute. But anytime you're talking about states of matter, if you boil water and you cool it back down, it turns back into liquid water. So this is going to be physical as well because no new substances, it's still water. This next one, number 4, sucrose decomposes when heated. First off, I guess you need to know what sucrose is. Sucrose is sugar. All right. Anytime you see something in chemistry that ends with OSE, it's probably a sugar. Like lactose is milk sugar. Dextrose, fructose. You've heard of, some of these words before. Like high fructose corn syrup, maltose, galactose. Anything really that ends with glucose. That's from your days as biologist. Things that usually end with OSE tend to be sugars. The word decompose, I guess we need to know what decompose means. Decompose simply means it's breaking down, right? So decompose means that something's breaking down into its component parts. So sugar breaking down when heated, that's going to be chemical because it's turning into new substances, decomposing. Sugar tastes sweet. This one's kind of a weird one. Believe it or not, this one can be either. All right. And so that's a little tricky. You think, well, sugar tasting sweet. Definitely physical because here's the deal, guys. Taste and smell, those two senses are kind of closely related to one another. Essentially, what happens is you have taste buds on your tongue, right? And you can taste, what is it, sweet, sour, bitter, and salt. So you get like 4 different tastes. I don't know, maybe savory too. I think I've heard somebody say savory, but anyway, you guys have heard there's different kinds of taste buds. Well, you might be curious how your tongue or how those taste buds identify these different tastes. Well, believe it or not, it's looking at shapes of molecules. And so it's kind of like a lock and a key. Your sense of smell works the same way. You have olfactory nerves that when you have certain molecules and they have certain shapes, they can get in there and they can activate these nerves and it'll send a signal to your brain. It's like, oh, that smells like vanilla. Oh, that smells like lilacs. Oh, that smells like rotten eggs. Taste is the same thing. So as your tongue, as these taste buds on your tongue, these nerves are activated by these certain molecules that fit into these receptors, your tongue says, oh, that tastes sweet, that tastes salty, that's bitter, whatever. So there's definitely a physical component. Chemical, anytime you taste something, it gets into your mouth and it comes in contact with saliva. Okay, so your saliva is there. It's what actually starts your digestive process. And so you've got enzymes and things in there that start breaking down foods that you eat. So anytime you have something with taste, I'm really going to count either. So either physical or chemical because there's components of both. Number 6, it says silver tarnishing with sulfur in the air, or silver reacting to tarnish. I guess you need to know what this word tarnish means. Tarnish is a lot like rusting, all right? And so silver tarnishing, if you've ever watched any of those shows like, what was it? Oh, Pawn Stars. That one where people bring in old stuff to the pawn shop and they try selling it for money. The guy who runs it, his name's Rick Harrison. And the first thing, if somebody brings in old coins, he asks him, he's like, you didn't polish them, did you? And the reason why he doesn't want people trying to polish those coins is because when you're polishing those old silver coins, you're actually removing that top layer of metal. Because it's undergone a chemical change. That silver is no longer silver. It's going to be a silver sulfide. And when you polish them, you're actually just rubbing that top layer off and exposing the metal underneath. What happens as you do that, you destroy the definition and the fine detail work on the coin. And that's what all the collectors are interested in seeing. So I think that's probably a good place to stop for today. Because we're going to do this next thing. It's going to talk about chemical and physical changes. We're going to do that tomorrow. So that'll be the first video, and we'll see you next time.